Okay, hello everyone. I'm really happy to be at the FableConf again, third time in a row, and I'm really happy that the conference is growing and super happy to see you all here. So, after this introduction, this was only Fable content during this talk, this introduction about FableConf. This talk is not really connected to Fable, it is connected to Fsharp, and by extension to Fable. But if you're interested in like, oh, just pure Fable talk, that and there won't be a lot of things like that inside. Yeah, and there will be, I recently noticed that this talk was classified as a talk for all levels, which caught me by surprise. But yeah, we will do. There's not a lot of technical stuff in this talk, so I think we all should handle that. My name is Chris. I've been active in Fsharp community for a while. I've done some stuff. I really like photography, so I will be talking a lot about photography, and all my slides have those beautiful pictures of Antwerp. So you know, if you are from Antwerp, you can feel more welcomed on this talk because here there's like emotional connection between me and the slides and you. So yeah, that's fine. You can follow me on Twitter if you don't. Yeah, so warnings. Yes, as I mentioned, there is not a lot of Fable in this talk. So that's warning number one. The second warning is that I probably will give opinions in this talk. So if you don't like opinions, then this might not be a good talk. So let's start. Building editor tooling, building tooling in general in the language. Building tooling in the language starts with the compilers. Is Don in the room? No, Don is not in the room. I'm so happy. I don't need to talk about Fsharp compiler in front of Don. So compilers 101. Compiler usually, if you've read any book about compilers, or you take a university course about compilers, or you've written your own compiler in like 100 lines of Fsharp code, that's what is required to write compiler, have several phases. And compilers are often basically black boxes. You know, you send some files to them, some magic inside happens, and you get some nice executable, nice library, nice DLL. Oh yeah, sorry, I'll do that. That probably will be better for the recording. So this whole thing that's here is basically black box. And also in typical compiler design, every of those phases is also black box. Some stuff comes here, magic happens. Some stuff goes out, comes here, magic happens. As you can see, this is probably fairly similar to functional programming. And by the way, the family of the languages that Fsharp belongs to is called ML, and ML means meta language. It was language that original idea behind ML was to create a language that's perfectly suited for creating compilers. So yeah, that's fun. So when I had university course on compilers, before I've dropped out from the university, they've told us, oh, you should write compiler, but you cannot use any ML language because that would be cheating. Yeah. So whoops, sorry, I need to point here. Okay, I need to remember that. So a couple of phases. First one is lexer. Lexer takes a text as a normal string, and it produces set of tokens, list of tokens. So it's like, oh, the first token is let, second token is white space, third token is X, fourth token is white space, and so on, so on, so on. So this is like simple operation. The second phase is parser. Parser takes this list of the tokens and transforms it into a structure called abstract syntax tree. And Florian in the morning mentioned a bit abstract syntax tree. But in principle, abstract syntax tree is just a tree which represents syntax, and it's abstract in a way that it represents bit higher level of abstraction. So it's not token by token, but for example, if then else block can be one node in your abstract syntax tree with couple of childs. So that's why we call it abstract syntax tree. The third part is type checker, and type checker is kind of like complex, but in principle it takes this abstract syntax tree and performs all the typing validations, all the typing checks. In case of Fsharp, it performs also type inference. So you know that if you have code let x equals 1, that this x is integer. On the level of abstract syntax tree, on the level of parser, you don't have this information. On the level of type checker, you will have this information because we've performed all the operations related to types. And typed abstract syntax tree is this bit that probably contains most of the information. It's on even higher level than abstract syntax tree produced by parser. It contains more information. It contains less information about code structure. So parser produces abstract syntax tree that is somehow connected to the structure of code. Well, in a bigger way connected, better connected to the structure of code. Type checker and typed abstract syntax tree is abstract, really abstract. Then we have optimizer, code generation, binary emit. I won't be talking about that because that's not really interested for us during writing editor tooling or tooling in general. And also what's really important is that here we have also external references, and that's completely different, separate part of building any tooling, especially in .NET, because MS build and resolving references in .NET is a bit magic, and I won't be talking about that because I really don't like talking about that. So yes, so we have this black box approach. We do stuff, we send them files, we get back DLL, and that's not really good. That's like not good enough to build modern editor tooling. And what I mean by modern editor tooling, yes, I have a beautiful slide. So modern editor tooling is responsive. Modern editor tooling is rich, so you have all possible options, all autocomplete tooltips with a lot of stuff in tooltips. It should be obviously performant, but that's not always the case. Yes, we all know. And it should be context aware, so it should somehow be connected with what's happening in your text. So there shouldn't be. Have you ever used Visual Studio? Probably anyone haven't used Visual Studio ever? Okay. Have you ever used object browser in Visual Studio? This is like this terrible window that's opened on top of your code, where you can click through namespaces. And here you have file somewhere. But no, this object browser is totally not connected to this file. Why? Why would you just like click through namespaces? Yeah, that's terrible. So it shouldn't be like that. It should be context aware, so it should be somehow connected with what you are doing right now in editor. Obviously it should be correct, because if our editor tool gives us list of autocompletes, we kind of want to believe that this is complete list of autocompletes, and we don't need to type something manually. So this compiler Blackbox is not good enough for that, for multiple reasons. First of all, if you have compiler Blackbox, then you need to perform whole compilation process, and then you get artifact at the end. Then you can somehow look into this artifact and start figuring out those autocompletes and things like that. This is not good, because this means that you need to perform whole compilation process on whole project. Oh, thank you. And yeah, that takes time. That doesn't react on the changes that you make in file. So you need to save the file, build the project. And there are a couple of languages that are using things like that, but let's not talk about them. Let's talk about Fsharp. I've stolen this slide from Philip Carter, Fsharp project manager, and he said this really great point. He said that compiler nowadays needs to be a server, so a long-running process. It's not just something that you run it completed and it's finished. It needs to be API, so you need to be able to call it in programmatically way. You need to be able to code it from the code. And it needs to be a database, so you need to be able to query internal state of the compiler. Because it's a long-running process, it has some internal state. You need to be able to access that. You need to be able to use information. And in case of Fsharp, we have this awesome project called Fsharp Compiler Service. Fsharp Compiler Service is a version of, or a fork of Visual Fsharp compiler. Well, it's not now .NET/Fsharp compiler. It has been created by Fsharp community, especially by like Thomas Petriczek and Dave Thomas. They've done a lot of stuff on that. So before Fsharp compiler service existed, the way to create Fsharp tooling, because Fsharp was always focused on editor tooling. That's kind of like it's Microsoft language. Microsoft is about providing good editor experience in their languages. So they've provided pretty decent experience in Visual Studio, but people wanted to use Vim or Emacs or some other magical stuff. So what initially those editors did, they've actually took normal version of the compiler, compiled fsc.exe, and they've used reflection on top of that to access private APIs. But that was not really sustainable in a long way. Like reflection is a mess. It's slow. If something has changed in the compiler, then this whole reflection thing had to be rewritten. So Thomas and Dave and a couple of other people in the community created Fsharp Compiler Services. Fsharp Compiler Services is basically fork of the compiler with several APIs, additional APIs exposed. It's literally another project file put on top of existing code, so it's including the same files that are included in the compiler, and then it's including also the Fsharp signature files, FSI files, and they are changing the private to public in those places. So that's all. That's all what Fsharp Compiler Services does on the base. On top of that, it adds a couple of additional APIs that make it easier for us to write tooling and widely understood tooling on top of Fsharp. So it looks a bit like that in this case. So we have Lexer, as in Lexer, but we have API on top of that can communicate with Lexer, and Lexer can communicate with API. There is like both push and pull communication in most of those cases, not always, but it's there. Lexer will be used for things like, I hovered over something, so I've put my mouse over something. Should I display the tooltip for this? Is that actually some text, so it's some identifier, or maybe it's just dot and you don't want to display tooltip for dot, so you don't want to do more expensive operations. You want to stop computing as soon as possible because every operation is expensive and tooling should be pretty fast, hopefully. The second part is parser. Again, parser is just parser, but we have abstract syntax tree on top of that. And abstract syntax tree will be used for things like formatting. Thomas guys knows way more about that. For things like validating the breakpoint position in Visual Studio. So when you put breakpoint in Visual Studio, they've actually checked if putting breakpoint on this line makes sense. So if it's not like just opening bracket or something. Then we have type checker, and on top of type checker we have two basic APIs. One is Editor Services API, and Editor Services are basically used by all editors. And there is also Symbol API and typed abstract syntax tree API. So let's go. And what is important? Those things. So Lexer and API up to this thing. This runs in long-running process inside. This is distributed as library. You can run it in your own console application. You can run it in web server. That's what we do in FS Autocomplete, and I will mention that in a moment. So yes, so abstract syntax tree API. Abstract syntax tree is a structure that's in Fsharp, in ML languages, is represented as discriminated union. That's how we basically usually represent the tree structures in languages like that. So it involves a lot of pattern matching. And yes, as I've mentioned, it's used to implement features like formatting, like any feature that's based on the code structure. So that's directly connected to the structure of your code into some refactorings. So I will quickly try to change the screen, if I'll manage. Yeah, there is this beautiful tool created by our favorite people here in this room that totally changed way we work with editor tooling, and it's helping a lot. It's like visualizer of the abstract syntax tree and typed abstract syntax tree that's online, and this is really nice for debugging and figuring out what's wrong usually with my code. Where is mouse? Okay, so on the left side I have some Fsharp code. It's nothing special. It's just module and a couple of LED bindings. And on the right side I do have well, there's a couple of representations. We can view it as a JSON or as a nice graph, but it's basically a representation of abstract syntax tree. And if you show graph, yeah, it's pretty big. As you can see, it's pretty big. Like, I won't go into details, but what I would just want to show you is that, oh, there's quite a lot of nodes here, and there's quite a lot. It is high level, it is abstract, but it's still directly connected to the code structure. So if we go back to JSON view, we can find things like LED binding. So there is LED, and then LED as a child has binding, which is normal binding, and yeah, there's like a lot of info here, and I don't have any idea what most of this stuff means. Let's go back to slides. So the second thing I've mentioned, the second part I've mentioned is Editor Services API, and Editor Services API is pretty low level but useful layer on top of Fsharp compiler services that provides common functionality that are used in editor. So if you get list of autocompletes, this API is used under the hood, and that means that all Fsharp editors or all Fsharp tools potentially will provide you with the same list of autocompletes. The same list you will get in Visual Studio, the same list you will get in Visual Studio Code, and in Vim, and in Rider, and in Visual Studio for Mac. And this is really important, because such ubiquity of tooling is not something that you can see in most programming languages, especially not in functional programming languages. It's really common for functional programming languages to like have one editor that's working well, and it's Vim, and you don't know how to quit. So you know, I don't want. I want some. I know that I code a lot, but sometimes I want to quit. So yeah. So having it in Visual Studio when I can just like Command Q, this is nice. And it's based for many features. So it's. Initially, when I started working with Ionide, with FS Autocomplete, that was what we've been using, and it was like successful. I mean, a lot of people started using Ionide pretty quickly. But nowadays, we kind of treat it as a base, so we take those information that are ubiquitous, and then we enrich those informations with other stuff. The third really important thing is Symbol API. And Symbol API is basically this database query of state that I've mentioned. So after we've type checked the file, we can also get access to all symbols that are defined in this file. And symbol is basically anything. Like LED binding is a symbol like X. Your class that you defined is a symbol. The record is a symbol. The module definition is a symbol. Everything is a symbol. And Symbol API gives you access to those elements, and what is most important, it gives you access to all type information about those objects, those symbols. So you know that your x is of type integer, and then you can go to type integer and check that type integer have such list of the members. And that's, for example, what is used in Ionite's info panel. That's what is used to create the function signatures in code lenses or in any other places. That what is used to format signatures in tooltip in Visual Studio Code or in Rider or in Visual Studio Code for Mac. Visual Studio doesn't do that. So there is like these nice line breaks whenever it's new parameter and things like that. There is nice formatting of signature in tooltip. So this is like all this information that we have access to. We are using that to enrich experience of the users. And many of the features are using by combinations of those APIs. I've grouped them into several groups, but this is not something strict. This is not any strict grouping. Basically, almost every feature is using combination of those. As I've mentioned, displaying tooltips. First, we check if displaying tooltip for this position makes sense for the using Lexer API. Then we use Editor Service API to get basic result, so basic text in the tooltip. Then we are using Simple API to enrich that information with additional information we put in the tooltip and with signature formatting and things like that. So yeah, so it's complex system that there are many features that using many different APIs. But let's take a step back. I went here with like details, but actually how it works, how Ionite works, and how different tools plugs into this system. So on the bottom of everything we have Fsharp compiler services, and this is super important because this is this component that enables us all working on different parts of the tooling ecosystem to do that. We have tools like Fsharp Linter or Fantomas, which are just normal tools but can also be used as libraries. Then we have something called FS Autocomplete. I've mentioned it a couple of times already. So FS Autocomplete is this long-running server process that is hosting Fsharp compiler services. Fsharp compiler services is a normal .NET DLL. This means that in case of Visual Studio or Visual Studio for Mac, I can just reference that from my editor host, and it's fine. Unfortunately, in case of Vim, I cannot really do that. Like I can't use directly .NET DLL in Python. What's used for creating Vim extensions? Whatever. I cannot use in Lisp in case of Emacs. So community has created this long-running process called FS Autocomplete, and FS Autocomplete is exposing multiple communication methods on top of Fsharp compiler services. In the past, it was like HTTP and some weird protocol based on standard input and output, so just like writing text to the command line and reading from the command line. Nowadays, we are using something called Language Server Protocol, which is protocol proposed by Microsoft to establish some standard in the communication between language servers and tools. So this is really important, and FS Autocomplete is using Fsharp compiler services directly, but it's also depending on the other tools provided, other libraries provided by ecosystem. And I'm obviously lying to you because this part is Fantomas FS Autocomplete is not done yet, but will be hopefully soon-ish. It depends on them. Blame them, not me. Blame Florian. And then on top of FS Autocomplete has established communication protocol. There is some contract. On top of that, we can put editor plugin, either Visual Studio Code in case of Ionite or Emacs or Vim or anything else you want to do, and you can use it from the command line to if you're like doing something nice. And editor plugins are connected not only with FS Autocomplete but also with other tools like Fake, like FSI. So this is like complex system, and this has been one of my biggest problems when working with editor tooling is fact that problems of whole ecosystem are surfacing in editor tools. So your MS build is not working. Oh, that's Ionite's problem. Your .NET installation is broken. Oh, that problem shows up in editor, and that means that Fsharp is not working because Ionite is broken, and you should fix that right now. Yeah, so this is pretty complex system. So that ends first part of this presentation. That was kind of like mentioning some technical details, and the second part of the talk, I will share some of my experiences and maybe like design principles and how it all should work. How much time do I have? When should I end? Can I talk for a whole night or? Oh, awesome. That should work. So let's mention this slide once again. So editor tooling, there are all those features, those words that describe modern editor tooling, but it's not always as simple as just, oh, we need to have rich editor tooling. We need to have. It's really hard to get them all because, for example, the richer your editor tooling is, the higher chances are that something goes wrong with performance. It's pretty obvious. The more stuff something do, potentially slower it becomes. So building tooling is an art of balance between choosing what you want to do, whether you want to have as rich tooling as possible, as many features as possible, as much stuff happening in your editor automatically. But this may be slow. This may be not as nice to use. So it's art of the balance of choosing right amount of operations that should happen. This is especially important in case of Fsharp. So one thing I haven't mentioned, Fsharp compiler services is a single-threaded thing in principle. It has something inside what is called Reactor Cue. Reactor Cue is a queue on which we queue. That sentence sounds weird. On which we queue all the operations that we want to perform. So we want to perform type checking, it's queued. After type checking, we want to perform something, then something, then something, then something. And this is single-threaded operation. And being single-threaded is a huge limitation because obviously our editor tooling is, our operations in editor are not really single-threaded. It's like asynchronous system where multiple operations are happening at the same time, right? You start to typing something, it should type check your file, so display you errors, but it should also provide you with autocomplete, and it should also update your info panel, and it should also well, do some magic, whatever. So it's not so simple to just say, oh, we want all those things. Just implement them. It's not so simple. You need to choose right. You need to choose what is the most important thing for you. And for example, in Elm community recently, I'm also involved a bit with Elm tooling. And it's really nice for me to talk about Elm on the Fable conference. I guess that's good. So on Elm, recently, an Elm community recently started a discussion about state of their editor tooling. And there are some people that are heavily pushing ideas of, oh, editor tooling for beginners should be just syntax highlighting because that's what's fastest. So they are pushing idea that performance is the most important and the tooling doesn't need to be so rich. I personally don't agree with that, but that's just showing that there are different point of views. And it's out of the balance to choose the right balance, yeah, whatever. You know what I wanted to say. The second important thing is that everyone has their preferred workflow with tools. So the amount of time that people told me, oh, but that doesn't really work like I would want. This works perfectly in for 999 users, but for me it's like I would wish it was a bit different, bit like, I mean, why this is sending to FSI and like adding the closing semicolons? Why it shouldn't do that? So everyone has the preferred workflow, and you won't make, if you build any tool, whether it's editor tooling, whether it's some console application that's tool. Whether you build library, this doesn't really have anything to do with tooling itself. Whatever you do, especially in public, in open source, you won't make everyone happy. You just need to be okay with that. It's really important to say no. So I've made this mistake of not saying no multiple times in case of Ionite. So someone told me, oh, but this one small thing, this would make things so much better for me. And I don't know anyone else in the world that's using this feature, but it's in Ionite. And I don't really think that's the correct way to design tooling. You need to be focused on your goal, and you need to know what you want to do. You won't make everyone happy. You need to focus on finding good defaults in configuration. So the tooling needs to be working for 80% of the users out of the box. It should just work. Well, and the number 80%, this is like random number. It kind of depends on what you personally feel. But yes, it's important focusing on finding good defaults, especially when you start adding richer and richer features to your tool, to your library. Again, this is nothing to do with tooling itself. It's kind of like good advice. The more features you add, the more potential configuration you have, the more options you have. But by default, it needs to work pretty well for many users. So we need to focus on that. And we had a lot of problems with that in Ionite in the past. In Ionite 4.0 that we've released recently, we've changed a lot of defaults. So previously, in previous versions of the Ionite, we kind of used turn on all the features by default mentality. And that was problematic for many users due to performance problems with some stuff. We've changed that in recent versions of the Ionite, and I think everyone is happy about that. Well, maybe not everyone, but for those people who want those advanced features, they can easily turn them on. And most people that don't care, they just want to have some basic, good, fast editor experience. This is really good for them. Users, yeah. Users don't read readmes, and I know that I mean I don't like it. Don't feel that this is somehow I'm throwing shade at you. I also am user of many tools, and I don't read readmes. Tools should just work after installation, after like simple execution from the command line. It should be as simple as possible. It might not be perfect in this simple thing, but as I've mentioned in previous slides, finding good defaults makes sure that it should work just after installation, just from out of the box. And saying, oh, by the way, you should turn 3 different settings to make it work really well for you. It's not really like, yeah, this may happen, but this is something for advanced users. If someone is advanced enough, is using your tool for a while, then yes, he or she can play with the tools, with the settings, with the configurations. For the most users out of the box, you should just assume that they don't read readmes. So the installation process should be as simple as possible. Getting started process should be as simple as possible. And the configuration, default configuration should be as good as possible. User experience, this is my personal opinion. So I value user experience over end user experience over technical perfection. It means that I won't focus on fixing every single problem with my code to make it perfectly technically perfect, which is obviously like something that's impossible to achieve anyway. But if it's good enough for users, if it's doing the stuff that users want, I just push this code out, I release this code. I'm not fighting and waiting until this is perfect. And this leads to the next point, is there is tremendous value in the short feedback loop. There is like huge value in releasing as often as possible, and I've learned that from the guy at the end row, from Stefan, who, as you probably know, used to release like packet releases every 1 hour or something like that. Until NuGet team got angry that, oh, NuGet is not continuous integration system, you shouldn't use that. So yeah, so getting features to users as soon as possible is really valuable, especially in something as difficult as building tooling. Like, I know my perfect workflow. I don't know perfect workflow of you, everyone in this room. So I can have some design in mind of the tooling behavior, of the user experience behavior in mind, but I'm not sure if that's correct for vast majority of users. So pushing this code early to the users, letting them play with the feature, gives users ability to give me valuable feedback and to impact how this looks like in the future. And obviously getting feedback from as many users as possible is also important, and I kind of don't mention, I don't have slides about that, I don't think so at least, but I really put a high value on developer relationship, even when building open source projects. So just promoting your project, just getting connections in the community of people that will use early versions of your project and provide you valuable feedback. This is really, really important when building any open source project. Again, this is not something that's connected directly to the tooling or inherently to the tooling only, but this is something that I've learned during the building the stuff that I've built. And as I've mentioned, tooling to a degree can be treated as an abstraction layer. So as you have seen in the slides showing like general architecture, editor plugin is this small thing at the end, but it kind of depends on this whole ecosystem of stuff, on this all other tools. And it means that this editor plugin is basically an abstraction that makes nice user experience over all those disconnected parts of the ecosystem. This means that this is a good thing. You can provide nice user experience in the ecosystem, but it's also problematic thing from the point of view of vendor of tooling. It means that all problems are surfaced in editor tooling, in final product, which means that you need to be really making sure that this doesn't leak too hard, so that you handle errors correctly and put human readable errors on top of if Fantomas crashes, then you need to put like, formatting went gone wrong and not null reference exception or whatever, however may Fantomas fail. So yeah, I think I'm slowly getting to the end of this talk. And actually, I do have some Fable content, so I was lying. I'm always lying. So initially, when I applied for this conference and I've decided, I want to do a talk again on FableConf, my initial idea behind this talk was totally different. So my plan was to create some specific tool, some specific editor extension, or maybe like Ionite extension, that would work on top of Fable itself, especially on top of Elmish application, because I'm using Elmish during my day job. So that was interesting for me. It turned out that it was not so interesting for me. And hiking and photography was more fun than building yet another tooling project. So I haven't created this tool, but my idea was, okay, I will show you how Fable can fit into this world, and Fable can fit in multiple places into building tooling for people, for other developers. So first of all, both Visual Studio Code and Atom are written in JavaScript. Visual Studio Code is written in TypeScript. Atom is written in CoffeeScript, but they are compiled to JavaScript. They are using JavaScript as a language for the extensions and for plugins. This means that you can extend, using Fable, those two really good platforms, or one really good platform and another platform. You can extend those two platforms using Fable. And Fable works perfectly with that. So Ionite, maybe you don't know that, but Ionite is actually written in Fable. And we compile everything to JavaScript, and then we distribute this as Visual Studio Code plugin. Awesome. Ionite has been using Fable since version 0.1.11. So yeah, what is Zaid? I'm longer in the community than he is. Anyway, and before that, before actually using Fable, we've been using FunScript for multiple versions of Ionite. I think Atom version of Ionite was never ported to the Fable, but it kind of died anyway, so no one cares. And Visual Studio Code version of Ionite was ported to the Fable only in version 2.0. So there were like whole process before 1.0 and whole 1.0 release cycle of the Ionite was using FunScript. Then we've ported everything to Fable. So the idea of using Fsharp as a language in which we build tools for Fsharp developers makes sense. Mostly because the people interested in Fsharp tools are Fsharp developers, so we want to lower the barrier to entry to contributions as low as possible. If we used another language, maybe not all Fsharp developers know JavaScript. I mean, everyone nowadays kind of like knows something about JavaScript, but maybe they wouldn't feel comfortable with writing JavaScript. And they may feel comfortable with writing Fsharp code. So that's one thing. One place where FableConf fits into this whole process. And the second one is when we talk about tools, we often mention just like command line tools, for example, but there is also huge space of tools that are using some kind of graphical UIs. And Fable obviously is awesome for that. Either it's like Electron application or a local web server that's hosts some web page. I think that Angular, React, getting started template is nowadays also providing not only millions of the options, but also they are providing nice UI where you can click from options you can have in your when you create new application, when you scaffold. So creating something like that with Fable, it's its pleasure. And the second part is that, in my personal opinion, Fable needs more tools because we need to create that. This is how you see the strength of the ecosystem, that there are tooling, that there is tools that solves common problems, that helps you be productive, and maybe not even productive, but just makes your life better. Tooling is not only about making you productive, it's kind of just quality of life as a developers. It's not always something that will solve all your problems, but maybe something that will make your life a bit better in those small places. And maybe there will be other tools that will make your life a bit better in these other places. And that's how we increase the quality of life in our ecosystem, how we increase developer experience in our ecosystem. And that's really important for the adoption of the language. And I think that, yeah, you should try building some tooling. It's fun. You can then talk with people and have wonderful users. My name was Chris, and you can find me in all those places online, on Twitter, on GitHub. You can write me an email if you have any questions. You can find me on 500px, which is like photography website. I sometimes read books. It happens. I do have consulting company if you would be interested. And then you can help development of Ionite using Open Collective, which is like crowdsourcing platform for open source projects. Thank you.